Here's a review of the operation we saw in the first video, showing one of the streetcars leaving the lower station, traveling to the upper station, then reversing direction and returning back to the lower station. In this second video, part 2, we'll review the control panel, detectors, the bumpers on the Brill streetcars, the DCC switch on the cars, the wiring diagram for the control panel, flowchart, and commands used. Here's our control board for this operation. Here's the key component, our programmable train controller, also known as an NCE mini panel. That's basically the heart of everything, and we've got an Atlas number 56 momentary push button switch wired. One way it does a reset and the other way it does a start. In other words, it's this side is wired to the number 1 input, which is our start input. This side of it's wired to our reset input, which stops it from operating when we normally don't need to use a reset except when you're testing things or if something goes wrong, but you need to have it available. And then these are Atlas number 205 slide switches, and we just have all these hooked to the different inputs of the controller. And by closing these, I don't know if it shows in the camera, but it says off away from the camera and on toward the camera. In other words, if we push them this way, we're off. At this point, we've got everything off except I'm going to close the repeat switch. And one other thing to note, when we push the reset button, we get a red blink out of this LED. I hope it's picking up in the camera. And also when this sends a command, that blinks, and we can use that to test the detectors back there. But what we've done, all 4 cars are deselected, but we can still start the program if we got the repeat switch closed. If you watch the status light here, which is now green, you can see that went to red, and this thing is blinking continuously because the program is executing from top to bottom, so to speak. It's going through all 130 command places looking for things, and when it gets to the bottom, it says repeat, go back to the top, and we have a half-second delay. That should be blinking about twice per second, so that way we can see our controllers actually operating. And then if we open the repeat switch, you can see it stops executing. And again, if we close this repeat switch, push the start button, you can see it goes to red on the status light to show it's busy, and blinks to show it's busy. And if we open the repeat switch again, you can see it stops blinking and goes back to green. We get that blink by sending a dummy command, throw turnout number 2000 to curved. I think that's the command we're using. There is no turnouts on this layout, but it happily sends commands even if there's nothing there to receive that command. That's how we can cause it to blink. Here's some notes I collected about voltages. This is from the MTH user's guide here. They recommend 18 volts maximum if you're running lighted passenger cars. We started out using the Power Pro, which also they say NCE. This is from the NCE manual. They say 18 volts maximum. Also had a problem running in reverse with Proto 3 locomotives when using the mini panel to send commands. So I tried the power cab, but that it seemed to be only putting about 11 volts on the track. It's rated at 13.8, but may have lost a volt or two going through all the wires. My meter may not be totally accurate. I'm not sure, but at any rate, we could run 2 streetcars just barely. But for 3 streetcars trying to run at speed 8, we couldn't do it with the bare power cab, so we added the generic booster. And with the booster, we could run all 4 streetcars like you see in the manual. In the past, we've used just the power cab by itself to run 3 streetcars at speed 4 and 3 locomotives at speed 2, but you get problems going to the higher speed 8 with the power cab just by itself. Now we're back by what we call the number 6 detector, which is the one we normally use for these demonstrations, which is right here. That's a Z-Stuff DZ1012 detector, block signal detector. It's infrared, and that's a DZ1008 relay on the back here that's almost covered with these wires. But when that's green, as it is now, this relay is open, and this is connected to the input 6 of the controller. That's why we're calling it detector 6. So it's connected, but it's not grounding the input because the relay is open. Now, if a train passes in front of that, it changes to red, and then when that happens, the relay closes and grounds input 6 on the controller, and that's how we know when our train is there. If we take our hand away, it goes back to green. These are kind of handy because they're basically portable. They don't need to be connected to the track, and they can be moved around as long as you got enough wire. And then further back here is a second detector we added for this demonstration, Detector 8, and it's the same setup, a DZ1012 relay connected to a DZ1012 detector connected to a DZ1008 relay, and again, when something passes in front of this, it changes to red and closes that relay. And for wiring these relays, I've been getting this wire off of Amazon. It's for RGB lighting, I believe. And I've been using the red and blue for the power to the detector, and then connected to the output from the relay, the green and the black. And so normally with this 4-wire cable, and this goes back to the front of the layout, to the power and the controller, but normally with this 4-wire cable you can do everything you need. Now with the second detector, actually this is the original detector, but with the second detector hooked in, we have an extra wire for the relay. We can use the same ground, but we need a separate wire for the second relay, so that's what this 5th brown wire is running back. So running back to the front, we've got the 4-wire cable plus this brown wire. If we were only using one detector or using the 2 of them in parallel like we did in the previous video, 836, we'd just have this one 4-wire cable running back to the front. Just as an FYI, there's some hookup drawings. One of them shown here for hooking up the Z-Stuff detectors to the Z-Stuff relay. This one's for the DZ1012, and there's a similar drawing for the DZ1011. The DZ1012 was used in this video, but the DZ1011 will work also. We've got the program executing without any cars being operated. You can see again the red LED is blinking about twice a second on the controller. Now what we'll go do is block the number 6 detector.
This is a key port trolley.
Now we push that car in front of that number 6 detector, the one coming on the upgrade, and you can see our status light is still blinking, but it's blinking about every 1.5 seconds instead of every half second, because that detector, when it goes to red and closes a relay, the program adds an extra second of delay. So that's kind of a way we can tell that detector's communicating with the controller. Now we'll do the other detector. Now we blocked the number 8 detector. That one's programmed so it adds an extra 2 seconds of delay. So what we've got now, we've got about a blink every 2.5 seconds with that number 8 detector being blocked. That's the one coming back to the lower station that the cars cross when they're running in reverse. So again, that's another way we can communicate with both those detectors. And if we unblock that, it'll go back to half a second. You can see when we unblock that detector, now it's going back to blinking about every half second. And if we open the repeat switch, and you can watch the status light here, if we open the repeat switch, the program stops executing and the status light goes back to green. Looking at the bumpers of these trolleys, on the Brill trolleys, which is what these two are, they have a nice the bottom of the body sticks out enough that if two cars bump, there's still about almost a 1/4 inch of separation in here where the headlights would hit. So if this Brill comes up behind and bumps this Brill, it's not bumping the headlight, it's bumping the bottom of the bottom of the frame here, which is good. We don't really want to have the impact go into our headlight. However, on the PCCs, it's not that way. You can see with this PCC, if this one bumps into that one, actually almost the first thing that hits is right there at the headlight. The way the bodies are, they don't have enough of a bumper on the front to really protect the headlight. So what we did on the previous video, where there was a chance they might bump, I put a piece of insulation on the back to provide a cushion if they did bump into each other. Incidentally, the PCCs work fine on this layout also. In fact, it was originally set up with PCCs. It's just that half the time you're running PCCs backward, which they never did in real life, so I figure it's probably a little more realistic to do this with Brill trolleys, which look the same running either way. What I've done with these things, I put a sticky here to tell me which is the front end, because these things essentially look identical on both ends. If you turn them upside down, you can figure out where the drive axle is. There's a single drive axle in the front. That basically tells us where the front is. And this one, you may be able to see there's an empty slot right here to put in the DCC DCS switch. This doesn't have it. I went in and cut the wire, which MTH tells you there's a wire you can cut if you want to run it on DCC, but then you won't be able to run it on DCS. But I had to cut that wire to run it on DCC for this video. I'll probably get a switch added later if I can. This car here, out of these four, one has the switch added. You can see right here where that slot, there was an empty slot in the previous car. There's now a switch that says DCC on the left and DCS on the right. So this can be switched back and forth between DCC and DCS. This was done courtesy of Dwayne Eberhardt, our friendly MTH authorized service person in Lewisburg, Pennsylvania. Here's the instruction manual for the Brill Trolley Proto 3, and on page 5 they have the instructions activating DCC mode, and they tell you how to go in and cut the wire. You can see it identifies here black wire, and over here it says cut the black wire to run it on DCC. Of course, you can see this is a 3-axle truck, so it's actually some kind of a 3-axle diesel, not a trolley car. When you get in these Brills, there's just a mess of wires in there, and there's a black wire in there you can really hardly reach. Very short, so it wasn't a pleasant experience, but I had to do it. Here's our control panel up here again, and here's our programmable train controller there. And now we'll come down to the drawing, which looks pretty similar. What I actually did was photograph one of the control panels before I ran the wires and used it for this drawing, and then ran the wires on the drawing. But again, here is the programmable train controller. It's officially called an NCE mini panel. It's made by a company in Rochester, New York, you probably heard of, called North Coast Engineering, which now goes by the acronym of NCE, but it's all manufactured and supported out of Rochester, New York. And then over here we've got an Atlas 56 snap switch and Atlas 205 connectors, and all these do is ground inputs to tell the controller we want to do something or we don't want to do something. And then up here is shown the connections to the Z-stuff detectors, and there's a separate Z-stuff detector drawing for hooking these things up if you use these in the AutoControls-dot-org Z-stuff album. This is all on AutoControls.wordpress.com, the documentation. But basically we have our 2 wires coming in from our power wires coming from our command station, and the drawing shows a Power Pro command station. And as I mentioned earlier, we actually used a power cab with a booster for this video. But at any rate, you've got power coming in, going on the red and blue wires on the drawing, going up to the track, and then going over to power the Z-stuff detector assembly. And the outputs of the Z-stuff detector are the black wire going to the ground here, and the 2 yellow wires from the 2 detectors. This one on the right is number 6, and that one's the number 8 detector. And actually, you can use almost any inputs you wanted to hook these detectors and slide switches up. It doesn't have to be the numbers I used. You pretty much need to use number 1 for the push button, the start button. That's shown up here as a start button. It's connected to input. It connects to input 1. You need to have the start button pretty much connected to input 1. And we've only got 1 start button on this system. If there was more starting buttons, it would be inputs 2, 3, and 4, and so on. But we only have 1. But these other ones, I just ran them to try to get the wires as neat as possible. But it doesn't have to be the inputs I used. If you use different input numbers, you just have to adjust the numbers accordingly in your programming. And that's about it for the control panel as far as I can think of. Here's a clip from earlier video 829 where we used just a single detector in the middle of a relatively short track. For this trolley video, where we have a longer track, we're using 2 detectors, 1 near each end. We can use some coins to show how this system works logic-wise. Here's our track denoted by this black line, our 2 detectors in red. Detector 8, our lower detector, and detector 6, our upper detector. And we'll use these 3 coins to represent our 3 trolleys. So the first thing we'll do is we'll run the first trolley around the loop and past detector 6, and then we'll start doing a time delay and run it down here. This would be the upper station in the video, the elevated station on the left. And then when we've done that, we would run the second trolley around here, around the loop, up the upgrade, and park it up by the upper station. And finally, the third trolley, we would run around the loop, up the upgrade, and park it up by the upper station. Now, in the video, we had 4. Here we've only got 3, just for simplicity, but they basically work the same. The important thing to note is we're running 1 trolley at a time, and each one parks in its own space. So it's a very simple system to work out control-wise. You just run 1 trolley at a time. You just have to make sure they stop independent of stop someplace where the other ones aren't trying to stop. So when we get them all up here at the top of the upgrade at the upper station, then we can turn around and run them back to where they started. So we turn around and run this one down and past the detector. And I should have mentioned, when they go past the detector, we do a time delay. So when it passes the detector, we reduce the speed from 8 to 4, so it's running in here slowly. And when that time delay ends, we send the stop command, and that's how we control where it stops. A longer time delay from when it crosses a detector will cause it to travel further. A shorter time delay will cause it to travel a shorter distance. So we bring the second car back the same way. We started up going down the incline and around the loop and past detector 8, and again we slow it from speed 8 to down to speed 4, and so it's kind of creeping in the yard area, the station area. We're doing a time delay, and we stop that car. When that's done, we start the third car coming down the incline around the loop past detector 6, and as soon as that crosses that detector, since it's the last car, we can immediately send the speed 0 command and stop it. So however long this car takes to stop is basically our shortest stopping distance. This controls where they have to stop, and then these have to be enough longer that they park without bumping into each other. Now we can look at a simplified version of the commands to run these 3 trolleys. We're calling this trolley 1, 2, and 3 for simplicity. If we start here with the commands going forward, we say select logo 1. That tells our controller we want to talk to this trolley. And then we say speed forward 8. And then we say wait till input 6 is ground. That's input 6 is over here on the upgrade. When that goes to ground, then it goes past that command. So this is really the important command. Then when that happens, we say speed forward 4, slow it down to a creeping yard speed. Then our time delay, quarter second times 36, that's 9 seconds. When that time delay ends, then we say speed forward 0. So those combination of commands get that car around the loop and parked over here where it's supposed to park. Our 9-second time delay brings us down here. And then looking at the second car, we say select loco 2, again speed forward 8, wait till input 6 is ground, speed forward 4, delay a quarter second, 6 seconds in this case, speed forward 0. So same thing as we did a minute ago, except different car number and different shorter time delay. So it comes around and it goes around the loop and parks with the shorter time delay. It comes around and parks short of this car. And then our third car is almost the same. We say select loco 3, which is this one, speed forward 8, wait till input 6 is ground. That's when it crosses the detector. But since it's the last car, we can stop it immediately. We just say speed forward 0. So this one travels around the loop and it comes across the detector. When it crosses the detector, we say speed forward 0 immediately. That means stop, essentially, speed 0, and it stops. So again, this is our minimum stopping distance. We're going to see with this car, and we have to adjust these two cars so they stop further away. And then returning, it's basically the same thing, but in the reverse direction, which is down here. To bring them back, we say select loco 3. That's the one we just ran. Speed reverse 8. Wait till input 8 is ground. Speed reverse 4. Time delay and speed 0. So that brings this car around over here and stops it at this end. And then we got the same thing, basically the same thing for the other two cars. There's the same thing for the second car coming back, and almost the same thing for the third car coming back. That's, we say select local. Here's our second car has come around and parked. Third car is almost the same thing, except again, when we cross the detector, we just say speed reverse 0, since it's the last car. Let's bring that one around. It's the last car. We can bring it in and stop it as soon as we can. So these are the basic commands used in this program. I've removed, to make it simpler, as I was saying, this is a simplified version of the program we're actually using. We've removed the logic commands where it skips over the cars if you're not going to run them, and the delays in reducing the speed on the upgrade and stuff. And then I should have mentioned in the real program, we get down to the bottom, we brought the last car back. We either quit if the repeat switch isn't closed, or if the repeat switch is closed, that means we want to do it again. We go back up to the top and start doing everything all over again. Here's our flow chart for this operation. This note says numbers in red show corresponding input and step numbers in the command file. That's like this number here and this number over here. That's input 7, step 1 in the command file. Those numbers are an attempt to link this drawing to the actual command file. In the other note, it says blue commands are optional. There's a couple places where we have commands in blue, and they can be considered optional commands. Now, when someone pushes the start button, which is up here, the first thing it does, it changes the status light to red, from green to red. That indicates to the public that the system is busy when that light changes to red. And then we've got our 4 switches that control our 4 cars. That's those Atlas number 205 slide switches. There's one of those for each of the 4 cars. And this is the forward direction here. And then down here is the reverse direction, because if it runs them forward, it's got to run the cars in reverse to get them back where they started. And then down below here, we have these detector tests. Is the detector number 6 closed? If so, it adds a second delay. Is detector number 8 closed? If so, it adds 2 seconds delay. That's how we can tell if our detectors are communicating with our controller. Then down here we have a delay a half a second and blink the LED on the controller, and that makes our controller blink when we're cycling through the program with no cars running. Then finally we've got this test down here. Is the repeat switch number 9 closed? If it's not closed, then the program quits and the last thing it does essentially is change the status light from red back to green, and then it comes to the end statement and quits. But if the repeat switch is closed, then it takes this path here, over here, and back up to the top, and across to the beginning and starts all over again. So looking at these in more detail, if we can run, as we mentioned, we can run any combination of the 4 cars. If we have, this is the switch for the first car, the second and third and fourth cars are shown in color, which corresponds to the color of the cars in the video. But if these switches are closed, it'll run that car. If these switches are open, it won't run that car, and that's in the forward direction. And in the reverse direction, it checks those same 4 switches, and here's the check for the reverse direction. In other words, for example, if we've got switch 12 closed for the first car, it runs it in the forward direction. Then when it gets down here and checks it in the reverse direction, it'll run it in the reverse direction. So it'll run any combination of the 4 cars. And then, as we mentioned, it goes through this detector test here. And I forgot to mention the first time through, there's a delay a half-second command here, and then blink the LED on the control panel. And that delay is to make it so it doesn't try to run at an infinite speed. If you don't have that delay statement in, I found it tries to run at infinite speed and it conks out, or I should say it just stops. So we put that half-second delay in there. Now let's look at one of the cars in more detail. We have, for the first car, we've got more detailed steps over here. This says select car 68, that's the number of the first car. Headlight on, speed forward 8. Now we have a 35-second delay in blue, and then we say speed forward in 5, and this is an optional set of commands. What it does is it tries to do a time delay to get that car over to the bottom of the incline, and then it slows it from speed 8 down to speed 5. Not necessary, but it just makes it look a little more realistic when it's climbing up the hill at a slower speed. Then we have our wait command, which says wait until the forward input number 6 is ground. That's our Z-stuff detector. So when the car crosses in front of the Z-stuff detector, that satisfies this wait statement, and then it goes on to the next one, speed forward 4, slows it down to the yard speed or station speed at the end of the line, a 9-second delay to park it in the appropriate spot. The next cars coming in will have shorter time delays because we don't want to run them out as far. And then when that delay ends, we say speed forward 0 to park that car. And then the flow goes back around here and over to the next car. We do the same sort of test for the remaining 3 cars. And we didn't draw that out in detail for each of these 3 cars, mainly for lack of space, but the notes here says Program B has similar steps as shown for Program A for car 68, and so on for the next 3. We do similar steps for these 3 cars as we showed here. The only real difference is the time delays are going to be shorter. So that takes care of running our cars in the forward direction. Now we're ready to go in the reverse direction, and we do that same test. And let's look at the first car that we have out in more detail. That's car 38. That's the red car. That would have been the last one to get run up the hill and park. So it's going to be the first one to come back. So going over here, what we see, we have a delay of 4 seconds, and that's just a pause before reversing. So that's so we don't come up the hill, stop, and immediately turn around and take off and reverse. We put a short delay there so passengers can get off or whatever. And then we have another select statement. This is actually already selected, but by having that in there again, in the test mode, we can start the routine here in the test mode. Now here we've got some optional command speed reverse 5, delay 14 seconds. That's so we go back down the elevated portion to the bottom at a reduced speed. Again, just an attempt to make it look more realistic. Then when we get to the bottom, we speed up to 8, which is our main line speed. Should have mentioned earlier, perhaps, our main line speed is 8, and then coming up or going down the elevated section, we're using speed 5. And then when we cross the detector and we're in the yard area or the station area, we're using speed 4. Now here's our wait statement. It says wait until reverse input number 8 is ground. That's the input the Z stuff detector will cross when we're coming in the reverse direction. So when we cross that detector, that satisfies this wait statement. It goes on to the next command, which is speed reverse 4, slows the car down the yard speed, have a 12-second delay. That's to park the car at the end of the track. And then we say speed reverse 0, which stops it. And then we come around and go back to our green car, the next car, and we do the same thing all over again. And these next two cars have routines almost the same as this one, except these delay statements will be a little shorter because we have to park each car a little shorter distance past the detector as we bring it in. Then we got our last car, and we bring that one back the same way. And as this note said, it's not shown in detail, but it mentioned there's an optional station stop routine in this for this car. There was space enough left to put one station stop routine in one direction for one car, and we did it for car 68 coming back in reverse direction. So that's how we run our 4 cars. And then again, we've got our 2 detector tests. And normally they're not going to be blocked when you're running cars. They'll be unblocked, so it just goes through here. But if you're doing the detector test, which means you've got these switches open such that none of the cars are running, then this program will be looping from top to bottom. And if you put your hand in front of a detector or push something in front of a detector, this will be satisfied. It will be closed, and it'll go over and add this extra delay, which slows down our blinking on the LED, and we can verify that detector is being recognized by the controller. Now here's our command file that shows our actual commands. The first page has a little diagram that shows the 4 streetcars and the 2 detectors. In other words, we're starting out going this way forward towards input 6. That's the input at the top of the incline by the upper station. Then when we get all 4 cars, or however many we're running, past that detector and parked in the yard or parked by the station, then we run them in reverse, and we go down towards input 8, which is our detector at the lower station. And here's just a reduced size copy of the control panel. Now on the next page, we just have some notes about which inputs are controlling which cars and which switches are controlling what. Here's the configuration of our controller or our mini panel. We're using the defaults except for these 2 where they're in red. We've got the memory set continuously 1 and above, and we've disabled inputs 2 and above because we use a 1 push button connected to input 1, and that starts everything, and we control everything else using the slide switches. And then down here actually is the beginning of our program, input 1, step 1, and here's where we change our status light from green to red. We have another copy of that little diagram. Now continuing on to the next page, we have the commands for the first 3 cars going forward, and these are all pretty typical. Let's look at this one here. This is the green car. It says skip if input 16's ground. That's the test to see whether the switch, the Atlas 205 slide switch is thrown to run that car. If it's not, it skips to the next part of the program. But if it's going to run it, we have a 4-second delay, and that's just to put a delay between cars, between the last car and the next car, and that delay is adjustable to whatever you like. Then we select our loco, turn on the headlight, speed forward 8, and then we have these 2 commands in blue, which it says commands in blue are optional. Delay a 1/4 second times 150. That gives us a 32.5 second delay. That's just to get us from the lower station over to the far end of the layout where the incline starts. Then we reduce the speed to 5, so we go up the incline at a lower speed of 5, just to make it look a little more realistic. Then here in the yellow is our way to input 6 is ground statement, and that's the detector. So when it crosses the detector, then we reduce the speed to 4. We do another delay to let it run in the station area at speed 4 for about 3.5 seconds, and we give the speed forward 0 command to park it. And in that, so that takes care of that car. And these 2 cars up here are pretty much the same thing. Then the 4th car is over here, and we do the same thing. Now this page starts the same thing all over just about, but going in reverse. So it's really almost the same thing. We have a slightly different things in blue. We go down the incline at a speed of 5. So that's what these commands are here. If we're using that optional going down the incline at a reduced speed, that's what these 2 commands do. Delay a 1/4 second times 50 seconds. That gives us a 14-second delay, which gets us essentially to the bottom of the incline in reverse. Then we speed up to speed 8, which is our mainline speed. Then wait till we get to detector 8. That's the detector at the lower station when we're going in reverse. And the same thing, reduce our speed to 4, do a delay. For the first car, it's going to be about 12 seconds to park it at the end of the track, and set the speed to 0. And then pretty much the same thing for the next 2 cars. And the last car coming back, which was the first one out, car 68, we do the same thing, except we had enough space to put in these commands for a station stop. That's what these commands are in blue here, the station stop. And we used this in previous videos. If you had less cars, you could add this for some of the other cars, but running 4 cars, we only had space to do this for the 1 car in the one direction going reverse. So that takes care of the last car coming back. And our last page is just our usual end statements. Here's our detector test. If either of those 2 detectors are blocked, it adds additional delay. That's when we're running the detector test with no cars selected, and we just have the LED blinking twice a second. And here's our statement to whether to continue or not. It says skip if input 9 is open. So that's the repeat switch. If that's open, it drops through and ends everything. First, before it ends, it changes the status light back to green. But if that switch is closed, that means we want to keep running. Then it goes back to the top of the program and repeats everything all over again. Just as a reference, this older program will also include in the documentation directory. We originally started out intending to run 6 cars on the level, and that's what this shows. Actually, 1 Brill and 5 PCCs, and that's what this program was written for. And it has, and this is before we had the inclined section, so we had no commands to slow the streetcars down as they climb the incline or slow them down as they go back down the incline. This is just bare bones, run them to the ends of the track. But there's car 1, 2, and 3 on this page. The next page has car 4, 5, and 6, and that's all in the forward direction. So when they're all running the forward direction, then we start running them in reverse. That's the last car, 6, to run it in reverse. and in car 5, 4, 3, 2, and 1 in our shutdown procedure. So if you do want to run 6 cars, this program, probably with a little tinkering, would do the job for you.